In this video, I want to talk about functools and the functions this module provides and how they can help you write better functions. Up first, we have cache. It's a decorator that caches the results of a function. When we use it with a function as a decorator, it automatically caches the function's results. The first call to factorial with 5 will take time because it computes all recursive calls, but subsequent calls return instantly from the cache as they have already been computed. Next is cached property. It's the same as cache, but for class properties. When we have a class property with expensive property calculation, the cached property decorator ensures the computation happens only once. For example, here we have a dataset class with an expensive mean property. The first time I access the mean property, it triggers the calculation, but subsequent accesses return the cached value immediately. Next up, we have LRE cache. It's like cache, but with size limit. It has a max size parameter, which prevents unlimited memory growth. Here we set max size to 3 for our Fibonacci function. The cache keeps track of the 3 most recently used values, and we can inspect cache with cache info and clear the cache manually when needed. Next is partial. Functools partial creates new function with some argument pre-filled, starting with a simple multiply function that takes 3 arguments. We can create a partial function double with x preset to 2. Now double only needs 2 arguments instead of the 3. Similarly, triple by 2 function has both x and y pre-filled. This is useful for creating specialized function from general ones. Next up, single dispatch. It creates function overloads based on the first argument's type. We start with the base function decorated with single dispatch decorator. Then use register decorator to register implementation for specific types. Each registered function handles a different type. When we call format value, it automatically dispatches to the right implementation based on the type of the first argument. This provides type-based polyformism in Python. Like single dispatch, there is single dispatch method or class methods. We define a method with single dispatch method decorator, then register implementation for different types. Each registered method handles a specific type. When we call the method, it dispatches based on the argument type. Next up, update wrapper. Update wrapper preserves the original function's metadata in wrapper function. Here we have an original function with its own docstring and a manual wrapper that calls the original function. Without update wrapper, the wrapper keeps its own metadata. After applying update wrapper, the wrapper appears to be the original function. This preserves important metadata like function name and documentation. Finally, functools.tracks. It's a convenient decorator for applying update wrapper. Here we create a timer decorator that wraps functions. The functools.wraps decorator preserves the original function's metadata. Without it, the wrapper would lose the original function's name and docstring. This is the standard way to create well-behaved decorators in Python. It ensures the decorated function maintain their original identity. That's all for this video. Thanks for watching. And if you like the video, do remember to subscribe.